fun test of whether or not a car is worth anything. It's an auto, it's in drive. I'm gonna open the door. It's gonna get mad, but will it still drive? Oh yeah, look at that. Modern car, still drive while in park. Hell yeah. This is a Subaru Ascent, by the way. So this is an R&D vehicle for RalliTEK Performance. This is a 100% stock Subaru Ascent. I believe it's a 2020. I'll check that in a second. So it's done some dirt driving already. Let's just look at a couple of quick features here. So this does have a top mount intercooler. This is the 2.4 liter variant of the FA. I'm not sure what they call this particular engine code, but it is turbocharged 2.4 liters, direct injected. So we have, real quick on first glance, intake air box, pipe goes down, turbo is down below, down at the bottom. This is the charge pipe that comes out of the turbo with pressurized air. You can see they did some cool stuff here. This is right here, it's some thermal shielding as well as probably some acoustic shielding. And then our coupler here, we have really nice clamps for the first time ever on a factory Subaru, and they reinforce the center like you see on diesel stuff. So pretty cool. And then more of this acoustic and thermal shielding up to the intercooler, which is a plastic end tank on the bottom, but we have a steel or a aluminum end tank on the top, which is another interesting feature. So typically it's aluminum. But what they did is on the hot side, they left it steel so that it can help dissipate some heat as well. Being that we don't have a turbocharger here like on a traditional Subaru where it's just going to heat soak, this is going to help increase intercooler efficiency. On the cold side, we're insulating it by using plastic, which doesn't transfer heat. Same thing with the intake manifold. It is plastic, which doesn't transfer heat, and they added this ribbing to make it even stronger. I've never broken one of the plastic ones. We ran well over 40 pounds of boost through them. But the fact that they decided to add some more support can't ever hurt. So, intercooler ducting. The top mount is not fed through a scoop on the hood like older Subarus. You can see it's a slick hood. What they've done is this entire grille section here feeds up above. You can see where the dirt is here. That's actually because this little outline comes up into here. And all of the nice cool air from that side as well as this side. And so this whole portion of the grill is ducted to the intercooler. So it should be pretty efficient. I know in the Foresters that had a similar design where they had the slick hood actually had very good intercooling as long as the hood is shut. So today when we do some dyno tests on this, we're gonna have the hood shut, obviously. So it's all loaded up. We're gonna do some baselines. Currently it's on 87 octane. Yeah, I said it, 87 octane. Regular gas. So let's see what it puts down. The next fun little thing I just noticed is Subaru has moved completely away from a coupler and a clamp on the intercooler to throttle body connection. This here is basically a brace that's bolting the intercooler here to the throttle body there. And I'm assuming, although I haven't taken it off, I'm assuming there's an O-ring inside this connection. And so the actual, what's taking all of the force and the load is going to be this brace here. And it is interesting, it's braced on this side here, and then down below it looks like there's another one that goes to the bottom side of the throttle body. And then this throttle body in general is a lot narrower than previous models. Most Subaru throttle bodies are quite a bit wider. So that's kind of an interesting look, as well as the throttle, can't really see it, the connector is different. This is going to be a T-map sensor, so it's got both manifold air pressure and temperature in it. It's a Bosch sensor. These are getting pretty standard. So there's a sensor here. There's also inside this one, which is the mass airflow meter, going to be an air temperature sensor as well. So this car, just like the previous models, have both. Now here's what's interesting. There might actually not be an air temp sensor in there because this is only a 4-wire MAF. And this is a different MAF than I've ever seen on any other Subaru model. So that's more, I guess, more fun new things. So we'll have to see if this has both intake air temp and manifold air temp. If it does, that's pretty cool. The last thing we need to do, or I should say attempt to do, is install our inductive pickup. Inductive pickups don't work as well on newer cars as they did on older cars. And the reason for that is coil packs these days are what we call smart, meaning that there's a very low current coming into the coil pack and then it grounds through the head. So to get a high current induction signal off of the wires to the coil packs is not simple. So I'm going to try to get this pickup onto coil pack lead, but I can't promise it's going to work, and if it doesn't, we'll probably just for the sake of testing run a gear ratio on the dyno for horsepower and torque. It's not as accurate and it's not as repeatable. This is the best way to do it, so we're going to try really hard to get one of these installed. So down here in cylinder 1 is our best look at potentially getting this pickup to work. So we're just going to grab the whole bundle of wires. You got to make sure that the pickup is got the wires inside of the little horseshoe magnet. If not, it's not going to work. So we're going to try that and see if that gets us a good signal. If not, we can start grabbing individual wires, and if that doesn't work either, then we're SOL. On the dyno, we've entered some pretty basic information on the car. Subaru Ascent 2020 RalliTEK, completely stock, 87 octane baselines, 3,445 miles in the notes. That way in the future when we come back, we can see, you can see right now the correction factor, we're at 0.94, meaning it's going to actually read 6% lower than the horsepower the engine is making today, and that's because of the weather. It's 102.65 kPa, so we've got really good pressure, pretty low humidity, and low temperature, which equals a low correction. Let's see, none of that's doing anything right now. All right, so it's reading 1400 RPMs, and looks like we're at about 1400 RPM, so that's a good sign. Additionally, vacuum is reading -7. We'll have to see if it reads into boost once we get there. I put a probe in the exhaust. I'll turn that on and see if we get a ratio. It's probably going to read full lean at idle on these cars. They intentionally, with some cam profile funniness, they pump a lot of fresh air through the motor. But nope, we're looking pretty stoic right now. Everything's looking good to do some baseline pulls on this, so let's have at her. So a couple of things we want to make sure are off. You have to make sure the collision detection and the eyesight are off, as well as the traction control. And the collision detection and the eyesight buttons are up here, and the traction control button is down there. Right, that little guy. So if we leave those on, it's going to think that it's crashing the whole time we're running it on the dyno, and it's not going to let us do a clean pull. Now this is a the ABS and brake lighter, because I've already done a pull. That'll go away once we take it off the dyno. This is a CVT, but they simulate gears, so we want to put it into manual mode, and then we're going to use the paddle shifters to simulate the gear that we want to be in. So you can see it says it's in a 1, 2, 3, and then we're going to do this in simulated 4th gear. Now on the dyno, it's going to tell us down there at the bottom we have a gear ratio of 64, well, it's going to change a little bit, but basically 60 something. That's pretty much where we want to be on an all-wheel drive car. So I'm going to do a pull here. I want to slow down a little bit, start the pull around 2,000 RPMs. We're still in 4th, so let's do this pull. The handheld controller, to start the pull, we're just going to press the green button, and then it's going to start logging the pull. See the air fuel riches. My boost control, the boost logger is not working. Let's stop the pull. Let's save it. The car back into neutral, and then hit the brake on the dyno, which is this button here. So you can see our pull on that pull is a little bit stronger than the last one. I started the pull a little bit later, but it made a little more power up top.
Looks like 220 horse instead of 214 on the previous one. So we're going to go ahead and do one more pull. Unfortunately, I have no way to log the boost on the stock because my boost reference is definitely a vacuum canister, so it's not going to give me positive meaningful pressure. I'm not sure if there is a boost reference, but once we hook up the access port to this, we'll be able to see what kind of boost it's getting. So we're going to do one more pull. It's always good to have 3 for a good comparison. Now that the car is warm, the exhaust manifolds are warm, turbo's warm, intercooler's warm. All those things are warm. So let's do this third pull here. First gear. Get down a little lower in the RPMs again. And these are not loaded pulls. We're just letting the eddy, or we're not letting the eddy currents work. We're just using the basically the weighted rollers here. Like shifted or something weird there. Silly CVTs. Alright, so again we're going to go into neutral. And then hit the brake. Gotta save the run. So on the dyno screen to save the run, I just on my little handheld, it's gonna be super zoomed. I hit this back button and then the center one. That way I don't have to have it. And let's see where we end up. 221.51. We could keep doing pulls, see if it picks up 1 more horsepower, but I'd rather not force it to. It looks like we lost the tack a little bit on that last pull. The tack went up in there, so not a big deal, but you might have to move them about a mile an hour in order to see a good comparison. So that's the baselines.
So on that last pull, the pickup was falling out. I have it graphed by speed now so we can see it without the chatter. And these little dips in the torque are not actual torque dips. That's because it's using it's using the gear ratio that it's detecting to calculate torque. But the dyno is actually measuring horsepower. It's measuring the speed at which the engine can accelerate these rollers that have a known mass. So it's a very consistent way of measuring power because the mass of the rollers doesn't really ever change, aside from maybe some dirt and wear. But using the weighted rollers gives a very consistent horsepower reading from dyno to dyno. It doesn't matter where the car is at, it's going to read very, very consistently. So we can see that we did lose attack a little bit. Why did we lose attack on that pull and not at all on the previous pulls is the question. As it got hotter, my guess is these are actually probably tiny little misfires. If it sees a little bit of a misfire or a little bit of knock, the inductive signal is going to suffer from that. If the coil is basically, if the coil itself misfires, and this coil was on cylinder 1, if you get a little misfire, the inductive signal that it's reading isn't actually grounding because the spark plug itself, when it misfired, it didn't send out the spark. And so it misses being able to pick up the signal for those particular events. It's pretty common sometimes if you have a big knock event as well to see this happen. My guess is that's what it was. I didn't hear knock, but I'm guessing this thing on 87 octane making over 200 horsepower, it's probably got a little bit of knock up top. So we'll ignore that run. We'll go back to the one before it. Go over here to engine RPM. You can see the RPM did change as it shifted. And that was it shifting. That wasn't a misread on the pickup. So, but yeah, 248 foot-pounds of torque, 220 horsepower, and this is to the wheels. It's pretty good. This thing's rated at 260, so that's not a ton of drivetrain loss, especially through a CVT. Air fuel looks super rich like they usually do. You know, down in the low 10s, 10.6, 10.8, 11.5 through the middle. It doesn't hold a super lean ratio for very long, like most cars these days do. It enriches pretty quick. We're down into the mid 12s by 3,200 RPM. So I wouldn't say it's a dangerous tune like a lot of newer cars have on them. It looks like it's a pretty solid factory tune. We're going to load up the Accessport, but we're just going to use it on the data logging maps. We're not going to load one of their performance maps because we need to run this thing empty and get premium in it before we do that. All right, it's time to unbox this Accessport. Start out. It's improper unboxing. Nice packaging. I've got a sweet little your Accessport is finally here. Fun little card. We'll get into the accessory box first. What do you get with your Accessport on a Subaru Ascent? This is the part number sub 005. Brand new, just for the Ascent. So here's your cable. It's an OBD2 cable. This is the connection for the Accessport. This goes to the car. We're going to go ahead and take off the little zip tie there, because we're going to get right into that guy. And then what else is in this box? Just a really basic little mount. It's got a stickum and a little alcohol prep pad so you can prep the surface and stick the mount wherever you want. The Accessport itself, once we get into this bag, we'll see that there is a nice zipper case, pretty well armored. Comes with a USB cable. This is necessary for updating the firmware on the Accessport, and we're going to do that in just a second to make sure we're on the latest, greatest, newest firmware. Warning, installing this Accessport over another Cobb or OEM product may result in ECU or TCU failure. Super duper important. Not that important on the Subarus as far as I know, but on some of the Volkswagens and whatnot, if you try to install over a previous tune from somebody else, you can damage the car. So we'll take that out. This is new to some of the newer ones. This nice little Cobb Tuning, fun little keychain, sweet little like air tag. Oh, and then it says Cobb on the other side. Super, super trick. Instruction manual. Get rid of that. Piece of foam. There is the Accessport itself. It says maps are preloaded. Please remove the film, but there is free firmware updates, so we're going to go check that out in a second. The next thing, this is the holder for the Accessport. One kind of fun thing, these are magnetic. They'll stick to anything metal. Other way as well. So there's just a little metal plate in here, and it's going to stick. The other cool thing is if you have one of those cell phone holders that's magnetic in your car, boom, these stick to them really well. So you don't necessarily have to run one of these if you already have one of those cell phone holders. This guy meets up with, where did it go? I'm already losing my parts. There we go. It meets up with this little mount. It just sits in there, and then you can mount that wherever. So if that's what you want to do, there it is. The other thing that these come with, they have the gray faceplate pre-installed. They also come with a black faceplate if you like the black on black look. You pop this faceplate off, put that one on. So I'm not going to do any of that. We are about tuning, not about aesthetics. Last but not least, only one? Nope, there's two in there. I was going to say, there's usually two stickers. So two little tiny window stickers. These ones are the kind where you peel the backing off, put it on, then peel the front off. They look good on the car. I like to put them on the rear quarter windows. That's where I feel like most people put them. So we have our Accessport. Let's get this film off the screen because the film is unnecessary. And I wish they put the little tab like off the side to make this easier to get off, but you can just grab it in a corner. Film comes right off. All right, let's go plug this into the laptop and see if we have any firmware updates. Actually, I'm going to go ahead and plug it into the Dyno computer so I can show you the fun magneticness of it. She's going to sit there. All right, so we're going to open up the Accessport Manager, which is this little, I have a hotkey to it here because I use it a lot. All right, here we go. Accessport Manager booting up. It's going to start up. Nothing there. But up here where it says updates, we have the little exclamation point. So let's click it. So let me close some of these. Sorry, my folders are all open. My cabinets are open here. All right, so there is a bunch of firmware notes. We don't really want to read that right now. So we're just going to begin firmware update. This doesn't usually take very long. I haven't done a sub 5 before. but my guess is it'll take all of about a minute. So let's see. It's checking. Well, it's taking longer than anticipated, so I'm going to fast forward it. Well, I said I was going to fast forward it, but I didn't, because once it found its update, it was very quick. So it's just rebooting. You can see on the screen, it says, "Do not disconnect." I'm assuming that's pretty important. It's a pretty stern warning. I wouldn't recommend trying it to find out what happens if you disconnect. Back up to this guy. It's currently verifying flashes, making sure that everybody is, all the bits and bytes are where they're supposed to be. Ooh, it's sending in flashing update too. We had a bunch of updates. It's a good thing we updated this. Let's read through some of the map notes while it says bug fixes. Fixed an issue where the access port would generate an NA size data log when too many monitors are selected in datalog. That's a thing that's been happening for a long time, like years and years. Interesting that that's just now being resolved. Who knows, maybe they resolved it on other ones before. Engine safety, added support to prevent ECU real-time map change operation on a per map calibration basis. Interesting. Not really sure what that's pertaining to yet, but there we go. Access port update was successful. Click OK. And now we'll see again, we're going to have nothing here. Manage, because we don't currently have any cars installed to it. So let's unplug it here and go install it to the car. First thing we got to do to install it to the car is get our OBD plug and plug it in. OBD plug, where is it? Is it in the same spot that used to be? I don't know. Let's see. Let's use my camera. Oh, there it is. It's right here. It was right in the front for me. Nice of them. Some of the other ones, it's way back there. But, so I'm going to pull this up. I usually just put them over the top of the steering wheel while I'm on the dyno. Let the customer figure out where they want it from there. All right, now we're just going to plug this guy in here. Nope, wrong way. It only goes one way. It's not built by Apple. It's going to boot up. I'm going to shut the door so we can get rid of the chime. All right, here we go. Just going to give you some on-screen instructions. So we're going to install this now. I'm going to just click the on-screen install and see what maps they let us default to. Verify, oh, we're not on the on position. We better click this guy on. Oh, it was off. No, I'm not quite on. There we go. Now we're on. All right, please confirm that you match 2020 USDM Ascent CVT post recall 1. That's what PR1 means. Sure. We're just going to assume that that's right. We want to turn off something, just a quick tuning tip. We want to turn off as many accessory things as possible. Headlights off, radio off, HVAC off. If the battery was to go low during a flash, some bad things could happen. So we have a stage 0 reflash only. Ooh, we have an 87 plus economy mode, 87 plus valet mode, 87 plus stage 1. I like that. And then we have anti-theft modes. Let's well, we're going to start by doing the stage 0. And oops, we lost our focus here. We're going to start by doing the stage 0 because we want a data log a run, and then we want to do stage 1 and data log a run and see what the differences are. So stage 0, this will install the access port. Hit continue. Normally I don't recommend holding your access port while installing. I like to set them down or put them on the stand or whatever, because again, if you unplug this plug during a flash, it'll be really bad. I don't know how bad. Again, I'm not going to try and find out. I know part of Cobb's R&D process when I was down at their facility is they have people, little minions that sit around in cars and flash cars over and over and over and over again. And part of their process is to intentionally fail flashes. So they intentionally unplug the access port or let the battery die or do various things while the cars are flashing to make sure that they can recover them. Why this is important is because if you can't recover the car, say you're an end user, you're flashing your car, the flash fails, kills the ECU, you're out for blood. You hate this company now because they ruined your car and you have to go to the dealer and spend thousands of dollars to have the ECU replaced, or potentially, if you're lucky, pull the ECU out, send it to Cobb, have them fix it. That's a lot of time and money that you're out, and you're not going to like their product. So what they do is they do proper R&D, and they make sure that you're not going to run into that issue. I'm going to fast forward this part of the map because this is going to take a minute, but what it's doing right now, it's saving the factory ECU data, and then in a second, it's going to start flashing the ECU data. So we're just about done, 98. This is, again, it's just reading the ECU data, and now we're at 100, and that's just going to save a backup of what's currently on the car. Now it's about to flash the vehicle. So this is the important, super important part not to unplug. Yeah, it's going to flash. Oops, keep losing my focus. So it's going to take a minute. Again, I'm going to not make you watch me write the whole car, but when it's all done, we will start it up and do a pull with the logger running. Jump ahead a few percent. There we go. This is the flash, and flash is complete. It says turn and leave the key in the off position, and then hit continue. Make sure you do what it says. Don't just start pressing buttons or not. This is essentially resetting the factory computer. This is a super important step on these direct injected cars. If you don't do this correctly, you can run into some really weird run conditions and have to do the whole flash all over again. Turn on. So we want to make sure that the dash comes on when it says turn on, not just one press on the key, it's two. Okay. So now it's resetting the learning. So this is installed what should be a stock map on the car. So I want you to turn it off for 15 seconds. I have a timer on this screen. I can tell you when exactly 15 seconds has happened. But we can go ahead and hit continue and begin setting up the data logger. So under gauges on the screen, it's going to bring in, it's going to default. We're going to just tell it we want 6 for now. This is going to get you the little 6 thing. So right now that's just AC compressor switch. That's what it's set up to. So we're going to go in and we're going to change. It's been 15 seconds. We're going to start the car here. All right. First crank always after you flash takes a little bit longer. Don't think it's always going to take that long. So we're going to change the monitor. I like AF correction. That's going to tell you how much it's having to correct the air fuel, and AF learning. These two together kind of tell you how much correction is involved in getting the car to hit the air fuel ratio that it's supposed to. AF ratio right here, AF sensor ratio is a really good one to monitor. That's your actual air fuel ratio, and on these cars that should be super accurate all the time. Next thing we want is good old-fashioned boost. You gotta know how much boost you're running. Boost! So especially because the dyno doesn't know, because we couldn't get a good boost source. And we want to know what it's running for boost. The next thing is going to be dynamic advance multiplier. We want that to get up to a 1. See, it's down at 0.312. We don't know where it was before. I wish we did. That would be great to know. It'll go to a 1 if everything is super happy. My guess is when we do a poll with this map, it's going to make less power than our other ones. But it might not. This is how the car knows kind of what octane is in it, and it uses this more actively than on previous models, where people always thought on the older Subarus if the dynamic advance was anything other than 1, that their car was blowing up and you might as well just, part it out. But on these newer, the direct injected motors, they use this a lot more, dynamically. It's called the dynamic advance multiplier. They use it more dynamically to get the car to run the amount of ignition timing that it's supposed to. And I'll show you when we get onto the laptop kind of what that's doing. very briefly, because this video will get really long if we start getting into actual tuning. Last thing we want is, we're just going to change this over to feedback. The feedback knock. Feedback knock. Actually, I want fine knock learn as well. I'm not as worried about AF learning, so we're going to change the AF learning to the AF ratio. And then we're going to put this one down here to fine knock learn. Whoops. The fine knock learn is this is what it's remembered from knock, and this is what it's seen for knock. So the next thing we're going to do is we're going to set up the logger itself. That's just what's displayed, so we want to configure data logging, and we want it to log a whole bunch of stuff. So AF correction, yes, AF learning, we don't need all the other AF learnings, AF sensor ratio, AVCS, exhaust left, exhaust right, intake left, intake right. I want to know what my cams are doing. Pretty important. Accelerator position, that's good. Barometric pressure, I don't really care about that on a data log. We're at sea level. If you were at high elevation, that'd be more important. But boost, definitely. Closed loop fuel target, definitely. CVT temperature, definitely. Calculated load, definitely. Command fuel final, super important when you're logging. If I know what my air fuel is, that's fine. But if I don't know what I'm commanding, what's the point of even knowing what the air fuel is? Oh, sorry. Coolant temp, important. Dynamic advanced multiplier, important. Feedback knock, fine knock learn, good. Fuel cut mode, that's what I sometimes monitor. Fuel pressure, excellent. Fuel pressure target, excellent. Gear position, it's going to tell you which one of the fake gears you're trying to be in. Ignition timing, injector duty cycle, that's not as important on the direct injected cars as you'd think. It doesn't really read how you would expect, like the older port injected cars. Intake temp, good. Intake temp manifold, we were talking about this earlier. So there is an intake temp and a manifold temp. That's great. This is going to tell us our actual knock threshold noises. We could run that, but it may or may not work. MAF correction, MAF frequency, MAF VE. That's kind of interesting. We'll see. We'll leave those on. Oil temp, that's fine. I didn't see just a MAF. That's weird. There's not MAF voltage. Oh, it's because the MAF in this car is a digital MAF. It's not an analog MAF like previous Subaru MAFs, and it's reading a frequency like a Ford does. That's fun. It's about time they did that. That means that MAF will probably never max out no matter how much boost you're running. Not that you're going to run it that far, but this is telling us what's going to happen in the future for other Subarus. That's how Subaru does things. They put stuff into an SUV first, and then they roll it out into the sports cars. Requested torque. Roughness if we were having misfires. Now this is the boost stuff. TD boost error is going to tell us the target boost versus what we're actually getting and what the error is. Map ratio for TGVs, blah, blah, blah. Throttle position. They don't ever log vehicle speed. I don't know if that's a liability thing, like if the police subpoenaed your access port for your data logs and they saw you were doing 140 miles an hour, they could probably write you a ticket. I'm on a dyno. I can go as fast as I want, and it's legal. Wastegate position commanded, and that's interesting. There's commanded and actual. Let's see if it'll let us log all this stuff. We're going to find out. Let's save. Let's see if it's going to do it. Oh, yeah. So, what do we do now? I think we go turn our fans back on, and we do a pull. Expected on that pull, it was a little bit lower because that dynamic advance hasn't had a chance to go up yet. But for the sake of time, we know that that pull was the same. It's the same as the other pulls. It's a stock tune. So we're going to load that Cobb tune onto the car, and we're going to start getting some more fun data. All right, so here we go. Tune vehicle. Key on, change ECU map. Let's go to reflash. Let's run this 87 octane. Stage 1, we want
We don't want the economy or valet mode. We want stage 1. So here it is. We're going to run the Cobb OTS map, and then we're going to compare the logs and see what's different. And that'll be it for our video today. Actually, I'll real quick get into the dynamic advance and what it does, and then that'll be our video today. Now you'll notice this is flashing much faster than before. The first time it flashes the car, it has to write the entire ECU. Now we're just going to write the differences. So what's different between the stock tune and this Cobb Stage 1 tune. I'm hoping this thing makes some power. I want to see, I mean, I guess if we see 225, then we saw gains. My guess is it's going to pick up quite a bit of torque, probably be pretty similar top end. That's pretty normal for these newer cars, especially turbo stuff. They've got some breathing limitations up top, but down low they can usually make a lot more torque. There it is, key off, press continue. Key on, press OK. Gonna reset the learning. Key off for 15 seconds. So we're going to go back here while it's waiting for its 15 seconds and get back into our gauges menu so we can data log. This one I'll actually show you guys the gauges. We're going to start the car here. Alright, we're started up. Back to our gauges. Oh, look, the dynamic advance is 1. So in the Cobb OTS map, they're defaulting the dynamic advance to 1. That's interesting because that means that this first pull is going to be for all the beans and potatoes. And hopefully we don't have big numbers on the feedback and fine knock learn. But we could. We might. Sometimes these OTS maps see some big numbers until it can bring the dynamic advance down to where it's happy. So we'll let the car warm up for just a second, and then we're going to do a pull. Gonna set that guy right there. I'll keep the I should have set up the mount for the access port. But oh well. Oh, again, because I reset the computer, the collision detection has turned itself back on, so we have to hold the button for a second. Now it's off. And then traction control, same thing. Now it's off. So we're ready to do a pull. Let's see here. Maybe we can move this kind of up onto the dash. Get a decent video all of it kind of doing its thing. Yeah, that'll work. All right, we're in fake 0, or fake gear number 1. Fake 2nd, fake 3rd, fake 4th. All right, we are ready to do a pull. If I see really big numbers on these feedback and fine knocks, I might let off. We'll see. I'm very cautious on the dyno when it comes to cars, especially ones that, you know, people want to drive home. If it's a race car and we're just trying to make the most power possible, that's fine. But this is well, it's an R&D car, but it's also a daily driven car. So let's see what we got. Ready for a pull? No knock yet. It sounds faster. No knock, the dynamic advance is happy. A little bit of knock. So right at the top of the gear, you saw just a tiny bit of knock there. It pulled 1.41 degrees out of a feedback knock. The dynamic advance stayed at full advance. All right, let's see what we ended up with for power here. So let me save that run. I forgot to change the run notes. In fact, before I save that run, I'm going to go change those run notes so that we have noted that that was not a stock tune. So, 87 octane Cobb, stage 1, 87 plus. Mileage. We've done a couple on the dyno. So, completely stock, 87 octane Cobb, S1, 87 plus. Save that. Whoa, we got some power. Hold on. It did drop the tach a little bit up top, probably right where it knocked. We'll go over to speed so we can see it. Max torque, 262 foot-pounds. Let me take away. So I took the torque reading off just so it's a little easier to read, and we can see where our gains happen here. So right there at what was 89 miles an hour. I can add, I guess, the third graph and do this as RPM. Since the tach kind of freaked out, it's a little bit unfortunate, but we see, so at like 5,200 RPMs there, we picked up 20 horsepower. You can see, like I'd said, the very top, we probably weren't going to gain any. This is also where it saw that little bit of knock, so it pulled a degree and a half of timing out. Didn't really pick up a ton right in the mid-range either, but we did pick up power down low, not a ton, but 8 horsepower. And there's 10 horsepower and 10 horsepower. So we see pretty well gains of 10 to 15 horsepower for almost the entire power band, which is pretty good for just changing the mapping on the car and still being on 87 octane fuel. I'm sure if we can put this thing up onto 92, we're going to see some pretty decent power gains. So let's pull the data logs and see what that all looked like. So here we are. Got the laptop out. We're going to go ahead and plug this guy in and connect it. We're going to take a look at some data logs and just see what we can see. So these are the maps that are on it. Remember before that it didn't show any maps? Well, now because we have installed it onto a vehicle, it's going to give us a little bit more options. It's also saving the ECU backup that it took. Remember when it read the computer, it took a backup. Well, that's what it's doing right here. Saving factory ECU data. I'm going to go ahead and open up my Access Tuner while we're waiting. We'll get that booting. So here are the maps that are on it. I'm going to go ahead and I want to save all these maps. This is my first plug-in to the Ascent. I have a folder here, Ascent 2020. We're going to go ahead and make a new folder and call that OTS Cobb Maps. And then we're going to put all those maps in here. That way I have, oh, it doesn't copy paste. I'm just going to drag them over. So now we have them saved on the laptop so that we can compare them to what we're going to do here in the near future. So on the RalliTEK one, I'm going to, just for the map we flashed was this one, so we'll just put this over there. All right. So now the other thing we can do here is we can see, here we have data logs. These are the 2 data logs that we took. Uh-oh. Did I not log that last pull? Guess what, guys? We have to do another pull. The first data log was just me driving around, I'm pretty sure. Not driving around, but driving on the dyno. And let's see. I don't think that there was a wide open pull on this one. No, I did a little, yeah, that was just me cruising on the dyno. So that log is junk. This log is, oops, that's in my folder. This is the log of our baseline run on the, they call it stage 0 or stock ECU map. So this is the AF correction as it comes into the gear and then it goes into open loop. So this is the log of the pull, all the monitors we had. There's that little bit of knock that we saw right there. This was, oh no, this is on the stage 0. Yeah, this isn't the knock we saw. That was knock on the stock map. So let's do another pull and let's actually data log what's going on this car. So let me disconnect, eject access port, and
get my gauges going, and do another pull. So I just went ahead and did that pull, and it had a little bit more knock than the last one. I'll show you here. Subaru. Oops, I better refresh this guy. Ascent 2020 RalliTEK. So this was the first one. Tack pickup or tack errors and all. Let's just get rid of the torque. Oh, we gotta go to mile an hour. That was the first run, and then this was the second one. You can see it did some weird downshift thing down low. We had that happen on one of the earlier pulls too. But then up top, this was it. It pulled 2.81 degrees, whereas before it pulled 1.4 right there. So it's definitely, my guess is it's going to lower the dynamic advance pretty soon, just from driving around. Let's reset. Let's see if we can pull up 2020 so we can show you what dynamic advance is. CVT, Ascent, Cobb, Ascent, there we go. Ooh, the Access Tuner Pro. Alright, but the data logs. Did we connect? Yeah, we connected. So now we have this log number 3, and that's actually the log that we wanted. So, currently open, we have our data log number 2, and then we'll also open our data log number 3. So things to note. Let's go over to number 2. Data log number 2, we can see if we find our boost. Where's our boost? All kinds of stuff. So boost, we saw a max of 14.5 and an average of 13.2. And you can see it kind of spikes down low here, and then it creeps up in the middle and then drops off up top. So boost max 14.5. Let's look at our other poll. Is it this one? No, it's probably this one. It's number 3, yeah. So back to number 3. It's a little bit more zoomed in on this one, but you can see our max boost was 16.58. So it does make a little bit more boost. That was down here on that weird shift that it did, and then it kind of creeps up, but it still drops off up top. So just kind of things to look at, making a little bit more boost. I bet if we put good octane in this, we could run a lot more boost on it, especially down low to pick up some torque. But yeah, so let's see this knock. There it is. At higher RPM, knock sensor picked up some noise, pulled a little timing, gave it back, pulled a little timing, gave it back. So things to look at from the tuning standpoint. Here's the actual ignition timing. You can see we were at 4 degrees. And then it drops when it sees that knock, and then it starts giving it back as we come up to the top. So yeah. All right, so that's kind of the differences in the maps. About 1.5 pounds, 2 pounds of boost through the mid-range. That's where that extra power is coming from, even on 87 octane. So my guess is it just needs a little bit more octane with how dense our air is. The octane that we have here is just not enough with this crazy air density, and that's why we're seeing that knock. There's the difference there between no knock and then knock. All right, so let's get into this. I wanted to show you real quick. The last thing is, what is dynamic advance? Why is it important? So under ignition tables, we have advance dynamic and advance primary. So remember I said the multiplier, the factory tune, it was at like 0.3. Well, what that is this table here is essentially, oh, it's going to be open. So this table gets multiplied by that number. So this is engine load across the top and RPMs across the side. And this table here gets multiplied by whatever number it was that we were at. So if it was 0.5, we'd see half of this number. And then it gets added to this table. And this is how it comes out with your final ignition timing. And so the higher that dynamic advance, the more ignition timing you get. the lower it is, the less you get, obviously. So if you have octane that's not quite up to the task, the computer is going to lower that number in order to just, before you see knock, to prevent that knock. So like it pulled 2 degrees on that last pull. So if it dropped the dynamic advance to 0.5, well, let's see what kind of engine load we were at. I'm guessing we were around 2.5. Let's see, calculated load. There it is. Max 2.6. Yeah, I was pretty close by saying 2.5. And average, so up here we're at 1.84. 2.6, that's a funny number, right? 2.6. What did we see that was similar to 2.6? What happens if I multiply 2.6 times 100? I get 260, right? What did we have for torque again? I know the torque is going to look funny because the tach pickup dropped out. But where were we for torque? Oh, look, 260 foot-pounds. Here's kind of a cool thing. If all your math is working right, usually it's pretty dang close. Let's look up at higher RPM. Let's just get rid of horsepower for a second and get rid of that first pull. So let's see here. Let's switch this to RPM so we know where we're at. So, except my thing's not working. So let's do 5,500. 5,500. What are we at for engine load? Let's go over to 5,500 or so. Let's see, where's my RPMs? Too many things. So that's 52, 53, 54, 5,500. All right. So 5,500, our engine load. Come back up here. 209, which would be like 209 foot-pounds of torque, and it's making 207 foot-pounds of torque right there. So this is what I was talking about, how you can pretty accurately, as long as everything's working right, you can model your torque. Your engine load is very, very similar to your torque. This right here, this curve, see how it's shaped? Look at this curve. See how it's shaped? Even with this little dip right there. That dip is on the data log as well. So pretty cool stuff. Just start nerding out over this kind of stuff. Data is awesome. Let's see. Yeah, data's sweet. What else can I show you? We were talking about that dynamic advance. So, oh, there's an adder there. No, that's weird. Yeah, it's not really adding a lot of dynamic advance except for down at lower RPM, which is quite interesting. Now this is the stock map. I should load a stage 1. This is the Cobb stage 1, and what I wanted to see, the last thing, was this dynamic advance table. Are they running more advance? Nope, and yes. So they are using the dynamic advance more traditionally, where it's actually at higher loads going to affect the power output, which is good. I like that better, especially if you start running higher octane and trying to push more boost. So again, it adds a fraction of this table, either all of it or some of it, to the primary table, and that is how you get your actual final timing. I'm not going to go into it too much more than that today, but it is pretty cool to see that we did pick up 15 horsepower on the Cobb OTS maps, the 87 octane OTS map versus the totally stock car. So anyway, thanks for watching, guys. I hope you learned something, and we will probably fairly shortly have some RalliTEK OTS mapping available for people who want to take it a little bit further than the Cobb OTS mapping, and maybe even have some extra safeties involved, like closed loop fuel control out to maximum RPM and whatnot. So we'll do some testing on this and see where we end up. Thanks for watching.